Hello and welcome into this new video about normalization in database design. Um, I'd like to talk about why normalize your tables is not a very good advice for new learners, for people who are getting into database design and are still confused by it. So you can often see on all sorts of forums like Reddit or something, when people ask for table design feedback, they show some ARD diagram or a database scheme or something like that. And the common advice that they receive is normalize your tables, set in this way or some other way. Here's an example from Reddit. I don't have time to look at this properly, but look into database normalization and see if there are any errors that your implementation could produce, then try to normalize this. This is not a very actionable advice specifically. This doesn't mean that your database is like should be normalized or not be normalized or whatever. The problem is that this advice is hard to follow if you don't know what you're doing or have a very vague understanding what you're doing. Most probably when people ask for this sort of feedback, they are just confused. And the way to resolve this confusion is that they need to understand the business domain first. You can do that in 3 steps. First, you build the logical model. You define entities, attributes, and relationships. And you're not thinking about tables here. And that's why normalization is not yet a concern here, or denormalization. This logical model forces you to understand the business domain, and it helps you to resolve a lot of ambiguity about what you're doing, what you're building. Step 2, you need to choose a table design strategy. That sounds scary, but like you most probably at this level, you have to choose the most common table design strategy, 1 table per anchor, per entity, whatever. But even if you choose many, like some other table design strategies, there are about maybe half a dozen, maybe a little bit more. Most of those table design strategies will actually give you a normalized table design if you just follow it. So you have a logical model and you've chosen the table design strategy. And then you define tables and columns based on the logical model. This is a very straightforward process, basically. And it gets easier because you've already resolved a lot of difficulties on step 1. You already know what are your logical entities, attributes, and links. Later on the following steps, you can do the normalization for performance, but this is again separate question that can be solved separately from the previous 2. Here on step 3, when you have physical tables and columns, you actually get the idea of normalization, the concern of normalization. But if you just follow the table design strategy, you will get a normalized table design. What happens when you, like a lot of people, unfortunately, begin straight from tables in this way or the other? Like maybe they build ARD diagram, physical ARD diagram. That is basically tables definitions. What happens here? First, you're struggling with business requirements because you don't understand them clearly. Simultaneously, you're struggling with table design. You need to think about primary keys, foreign keys, indexes, physical data types, how to blah, 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 normalization, and so on and so on. And when you're thinking about two things simultaneously, you get confused. Here's another example. Somebody posted ERD schema, and this is the comment. Another place you are duplicating data is with brands. You would have a brand table and use the ID as a foreign key somewhere elsewhere. Bottom line, you want to normalize your database. The problem here is that the person who creates the ERD, designed the ERD diagram, they just needed to define a brand entity on a logical level. It's not about normalization. They just didn't use the process. And it's not about duplicating data. You cannot, it's hard to understand your mistakes when you're thinking in terms of duplicating data. You have to understand what's going on, and then you can, and only then you can use this as a guiding principle, but you do not understand that at that level. So you have to build a logical model, and you'll be fine. Another example. Actually pretty perfect, because in a well-normalized system, a customer could have multiple addresses, and you would keep all the new and old addresses. Old invoices would keep the invoice address as per the point of invoicing, and new invoices will keep the new address. It's not about well-normalized system, actually. It's, again, you have to understand the logical design behind this system. Do you have multiple addresses for customers? This is this is even a bit different situation. Like you have customer have one address, has one address that you send invoices to, but they can change it. And the old invoices were sent to the old address, but the new invoices need to be sent to the new address. We're not talking about database here, right? We're just talking about how business works. We could do that in, I don't know, 100 years ago. It would be exactly the same without computers, without databases. And to resolve it, you have to just create a logical model of this. You have to think about historized attributes, or maybe not attributes, and so on. Actually, this is an interesting example, and I'm going to talk about that specifically in a follow-up video. Somebody asked the question, is data normalization needed in 2024? Doesn't matter. One reply, yes, it is. Denormalization in many cases is just poor data model design. Logical data modeling follows a normalized approach. Following a normalized approach is as important as ever. I have two problems with this response. So first, as we know from first video in this series, denormalization, that is copying data in a different representation, is extremely common because it helps with performance and it makes some things more convenient for people. So saying that denormalization is poor data model design is obviously wrong. a lot of people, everyone does denormalization all the time. Second is that true denormalization is never anybody's intent. This is always just confusion. And we discussed that in the second video, where we tried to specifically build denormalized database schema. And we've seen that it becomes quickly becomes obvious that this is just super awkward and this is not what you want, actually. So again, the problem is that historically, database normalization was taught and still is being taught in a roundabout way. You often see like an explanation of normalization that says, here is an example of denormalized data. And here is how to normalize it to, for example, third normal form or whatever. And it's never clear why we started with denormalized data in the first place. Why couldn't we just do the obvious process of logical design that goes to normalized physical design, and then it's going to be normalized from the start? This is confusing for people who get into database design. As I said, most of the time, logical design plus some commonly used table design strategy leads to normalized tables. There are a couple maybe table design strategies used in real world projects that are that may actually be denormalized. But okay, we're going to talk about that in separate videos, because you can consider that virtually always you get normalized tables plus a bit of denormalization for performance, copying some data in different representation to get to make it a bit faster, but not a bit. So this process, building a logical data model and choosing a table design strategy and then building physical table design based on that strategy, is discussed in my book, database design book. You can look at the table of contents and see if it would work for you. So in the follow-up videos, I'm going to work through an example of customers and invoices, which is a bit about historized attributes, or maybe not attributes. Also more about, like, directly about modeling approach from the database design book. We will talk more about this data duplication, because this is also kind of people talk about that in a weird, confusing way especially for the beginners. And about ERD diagrams, why ERD diagrams is not a very good representation of logical model and physical too. All right, thank you for watching. See you in the next video.